We now talk about average power delivered to a resistor. So the instantaneous power delivered to a resistor, this is given as power is equal to I square R. So I is this instantaneous current. So this is the instantaneous current. So this you can write as this I is nothing but Im times sine of omega t. So this you plug in here, you get Im square sine square omega t times the resistance. Now the average value of power over a fixed time t, so this average value is given as 1 by t integral from 0 to capital T p dt. So this you should think of, you have taken power over small time intervals, you add them up and then you divide by the total time. Now this power P, you substitute this formula in place of this P here. So we have substituted this P here. So this we have substituted right here. Now Im square and R are constants. They do not change with time. So you take them out. So this is the maximum value of current and this is the resistance in the circuit. So you take Im square R out and you are left with 1 by t integral from 0 to t sine square of omega t dt. So we have to find this integral. So let us just find this integral in the figure. So if you see this figure here, this is the graph of sine square omega t. Now, so here I'm taking omega as 1 and we are varying time in this direction. So you can see the average value here is just half. You can see in this graph the average value is half. But let us also solve this integral directly. So here we see that the average value of sine square omega t is half, but let us solve this. So if you solve this integral, you get t by 2 minus sine of 2 omega capital T by 4 omega. Now you divide this expression by t. So this first expression, so this becomes 1/2. And then we are worried about the second expression. So in this expression you get, so we get minus sine of 2 omega capital T by t times 4 omega. Now for large time this will go to 0. So as t goes to infinity, this expression goes to 0 because this numerator here, because the sine of 2 omega t, this numerator is less than or equal to 1. So since this is less than or equal to 1, so this entire expression is less than or equal to 1 over t times 4 omega. So as t goes to infinity, this expression goes to 0. So you forget about this expression because this is going to go to 0 as t goes to infinity. You just get half. So in the end you get power average is equal to, you take this Im square times R and multiply it with half. You get this average power. Right here. But this does not look like the DC power. We want the average power to look like DC power. So DC power, so we have to replace this current with something. So we replace this current with something like I square RMS, where RMS means root mean square. So you replaced I square by 2 with I square RMS. So that is I square RMS is equal to I square maximum divided by 2. So we have replaced this term with I square RMS and then take root of both sides. You get I RMS is equal to the maximum value of the current divided by root 2. So this I RMS is called the root mean square current. So similarly we define the root mean square or effective voltage as voltage of root mean square is equal to the maximum voltage divided by square root of 2. Now since the maximum voltage is equal to maximum current times resistance, you can divide both sides by root 2. So we divide this side by root 2 and the other side by root 2. So this side divided by root 2 we put as V RMS and this other side divided by root 2 we put as I RMS. So we get a formula V equals to IR. You can write as V RMS is equal to I RMS times resistance. And you already have the formula of maximum voltage is equal to maximum current times resistance. So now we consider an example. So you consider an AC circuit. So this AC circuit has a light bulb, and this light bulb is rated at 100 watts power and 220 volt supply. So this is the rating of the light bulb. So then the peak voltage, peak voltage is always √2 times the RMS voltage. So when a rating is given to us, the rating is most likely in RMS. So for peak voltage, you have to multiply RMS voltage by √2. So this is the formula we are using. So Vm is equal to √2 times V of RMS. So that is what we plug in, and we got 311 volts. And the RMS current in the circuit is equal to, so you know the formula for power is equal to P is equal to I times V. So that is what we plug in. So power is given to us as 100, and this voltage here, this is given to us as 220. So you divide 100 by 220. As we said before, the voltage is RMS. So the current we get is also RMS. So the current we get is 0.450 as the RMS current. So now if you want to find the maximum current, you multiply √2 with 0.45, and this will give you the I maximum current.